but I'm also a photographer. And today, I've put together a portfolio of photos that captures the scope of my thesis work. The first photo on the left is a picture of a child who suffers from kwashiorkor. This is a nutritional deficiency, and it comes about when a child doesn't get enough protein in their diet. So currently, it's estimated that there's 20 million children who are suffering from kwashiorkor worldwide. When a child like this presents in the hospital, the treatment is very crude. The child is simply put on a high-protein diet, and it's hoped that the child will get better. But the reality is that 1 in 3 of these children will die as a result of their condition. The second photo is a picture of a liver, and I've chosen to include this photo because these children are ultimately dying as a result of liver failure. This is what my thesis work is all about, understanding why kwashiorkor patients have liver failure so that we can treat them better. The third photo is a picture of liver cells, and at this resolution, it's very difficult to see the inner workings of the cell, and completely impossible to determine what might be causing the problem. However, we can see that the cell is highly compartmentalized, that it's made up of several different cellular components. And the fourth photo is my favorite of these components, the peroxisome. Now the peroxisome is the site in the cell where the antioxidants are kept. So if you've been eating a lot of blueberries, or if you've been drinking a lot of red wine, you've been filling up your peroxisomes with the antioxidants that they need to function. And this last photo is very special to me because it led to a major breakthrough in my project. If you look closely at these peroxisomes, you'll see that inside each of them is a very dense protein cluster. Now by themselves, these are very small. However, if you add up all of these clusters in all of the peroxisomes, in all of the cells in the liver, then this becomes a very significant amount of protein. It's significant to me because it's what I've studied for the past 5 years. But I believe it's even more significant to this boy, and I'll explain why. Early on in my thesis, we had the hypothesis that a cellular process was being activated inside the liver cells of these kwashiorkor patients. The cellular process is called autophagy, and it's Greek for self-eating. Now what this means is that because these cells are not getting the nutrition they need from the boy's diet, they need to get it from another source. And in this case, that source is their own cellular components, their own peroxisomes. And now 5 years later, I can prove it. That these cells are consuming their own peroxisomes in order to get at the protein clusters. I believe that these children's livers are failing because their cells are losing their peroxisomes. And now I'm working with medical doctors who are developing a new diet for these kids so that they get the protein they need, but more importantly, they get medicine to help protect their peroxisome population. None of this would have happened without these 4 photos. Thank you.